know how far the Earth is from the Sun? 93 million miles. That is 150 million kilometers. Now, the light is the fastest thing we know, and it takes 8 minutes for the sunlight to get to the Earth. So that is very far. Now, this is a fact that most of us know. We learn this in primary school, or children will learn this early enough, and everybody has the perspicuity to actually remember that fact, and if you forget it, you can Google it up. It's a known thing. And sometimes when we know a thing for a lot of years, we forget how hard it was to gain that knowledge, and sometimes we forget how hard it has been for civilization to advance to where we are now, and how many years, how much effort, and how many people was involved in teaching us the thing that we all take for granted today. So I want to talk a little bit about how we got to figure out the distance from the Earth to the Sun and how long it took us to do that. First, it starts with a visual effect. We are very lucky because we have two eyes. With two eyes, we can actually determine better the distance to objects, and we can find out and actually see the world in 3D. Most animals have two eyes, the human beings have two eyes. And I'm sure that for as long as we had two eyes, we noticed that when we look at things with our both eyes open, they look one way, but when we close one of our eyes or the other eye, they look kind of different. So let us do a little experiment right now. Cover one of your eyes and look at me. Now cover the other one. Now do that alternatively. Now if you do that, you will see that I'm seen to be moving from side to side every time to do that. I promise you, I'm not jumping every time that you close one of your eyes. It's actually an effect, a visual effect. Every time that you look at something from this eye, your position actually changes from the object. And when you look at your eye, has a displacement and the position changes. So you're seeing like I appear to be moving with respect to the background, but that is not true. It's just a visual effect. And it turns out it's because of the distance between our eyes. So I'm sure very early I found out about this as a kid, and I'm sure every child has known about this for many, many years since the beginning of man. So this was the first realization we needed to understand before determining the distance from the Earth to the Sun. But it had to pass many, many years, actually thousands of years, before the next piece of the puzzle was ready. And it came when mathematics was developed. This happened during the classical times, during the Greek philosophers' era. They started to develop mathematics and the mathematical knowledge, and they came up with geometry. And one of the tenets of geometry, it states that if you have a triangle and you know the length of one of the sides and one of the angles, well, you can pretty much know everything about the triangle. You can know the distance of all the sides, all the angles. And that's basic trigonometry, and they developed that during the Greek ancients, probably 2,500 years ago, around that time. So that was the second piece of the puzzle. The third piece of the puzzle had to wait for several centuries still. And it happened in the 16th century when Galileo actually invented the telescope, and he started looking at all those things in the sky, and we realized that first the Earth is in fact round, and that the Earth is not the center of the universe. We're actually spinning around the sun. And all these little lights that we see in the sky, they are not the same. Some of those lights are actually spheres, like our own world, big balls floating around the sun as well, which are called planets, or the moons of those planets. So this was the third realization. Now all the pieces of the puzzle were laid out, and it didn't take long for somebody to figure out, well, putting all these three pieces together and found out this is an excellent way to determine the distance from the Earth to the Sun. We can use one of those little balls in the sky, and for that planet Venus was the perfect candidate. And we can see the planet Venus from two different positions of the Earth and determine by the displacement, which is actually called parallax, how far the Sun is from the Earth. So they set out to do that. They actually found out that Venus had to be closer to the Sun than the Earth, because from time to time we could see Venus between the Earth and the Sun, and we could see its shadow going through the Sun. And those passings, they are called transits. Those transits actually happen 8 years apart, in pairs. Each pair is separated by 8 years, but each pair is actually separated by a century, almost a century. So the first time occurs, happens past a century, you get the first pass, 8 years happen, you get the second pass, and then a whole century goes along. For example, the last transit was in 2004 and 2012, and the next one is going to be in 2117. So we know that Venus has to be closer to the sun than the Earth.